Welcome to everyone on the channel 6 GB of video memory. We are working with an Nvidia P100-6100 graphics card. This is an analog to the Nvidia GeForce GTX 1060. It has 6 GB of video memory. We are now going to try running Flux through the ComfyUI. A modified driver version 5.80.88 has been installed for this graphics card. We are using the ComfyUI portable version, released specifically for older graphics cards, which works normally with graphics cards that have CUDA compute capability version 6.1. Let's look at the ComfyUI launch shortcut. This is essentially the standard launch command for the portable ComfyUI version. Launch it. I have installed ComfyUI Manager extension. In addition, the dual GPU extension is installed in my ComfyUI. I have 16 GB of RAM. Let's create a new workflow. What do we need? We definitely need to load the Flux model itself. For this, I'm using the gguf model. Let's start the Process Explorer. We will monitor how much resources the ComfyUI Python process are using. So, the unit loader node for gguf model, we will be testing with the Schnell Q2 model version of Flux. The file size is about 4 GB, so it should fit entirely into our video memory and work quickly. Currently, approximately 500 MB of video memory is being used. I have disabled hardware graphics acceleration to prevent Chrome from using some of video memory, although it does not consume much. Since the gguf model does not have built-in clip models, we will load the clip models separately. To do this, I use the dual clip loader node for gguf. The first model is T5v1.1xxl encoder, Q3KL encoder. The second one is clip model. Of course, we also need VAE model, safe tensor. Next, we will need the text encoder node. The main actions will take place in the case sampler node. We will need an empty latent space, or more accurately, an empty latent image. For the Schnell model, 4 steps will enough. The CFG value is 0 as we are ignoring the negative prompt. We will leave this as is. We will need to decode the latent image using VAE model later. And we will view the resulting image using the preview image node and save it at the same time. So let's try running our process. For now, let's save it and then run it. The VAE model loading is being processed. Currently, the loading of the clip models is being processed. As you can see, the device where they are loaded is the CPU. Video memory is still very little occupied. And now the text encoder has started working directly. I left the request is empty. The text encoder is working for a relatively long time, and it's clear that it is working on the CPU. A 20-core CPU is occupied by about a third or half. Therefore, we will stop the process and slightly adjust our workflow. We are restarting the ComfyUI server. There is a node that allows us to specify the model to run on the graphics card. This node is from the multi-GPU extension. Since we are specifically interested in the clip text encoder, we will make this node, which loads the text encoder model, multi-GPU. Let's start again. Free memory on the video 5500 approximately. The text encoder loading is starting. Here is the increase in video memory consumption. As you can see, the text encoder model has been loaded. The text encoder node ran very quickly and the case sampler node has started working. Currently, the request for the Flux model loading. We can see the video memory filling up with this model, 3 GB. The entire Flux Schnell Q2 model weighs about 4 GB. (3,700 megabytes, if it to be precise). It says that it's loaded partially. However, despite these facts, it feels like it's fully loaded. And it's running relatively quickly, approximately 17 seconds per iteration. We need 4 iterations. Peak consumption is currently around 5 GB. A whole gigabyte is still in reserve. More accurately, even less, that's 4500 GB video memory. The Python process is about 12 GB for private bytes and 4.5 GB. You can see the numbers on the screen. Okay, the VAE decoder is working, it's processing very quickly. And we have gotten something. Let's introduce a query and try to increase the resolution by 4 times immediately. Let's see what happens with the video memory and the generation speed. Let's run it. The text encoder is processing again. Since I was running the ComfyUI server by default, the results caching was enabled and the text encoder has worked quickly. That is, there was not a redownload of the text encoding models as far as I understand it. They are likely cached in the RAM, therefore the process of moving them into video memory went quickly. They processed quickly, and here we are again seeing case sampler working. And by the way, video memory consumption is even lower. I think it's 4500 megabytes. But the iteration, as we can see, has taken about 16 seconds. That is, one iteration is taking longer this time. We have temperature monitoring at 60 degrees. Okay, 67 seconds per iteration. We need 4 iterations. Executing each iteration takes about 65 seconds. That is, somehow video memory is being used even less with increased resolution. There is a lot of free video memory remaining. Let's go back to 500 pixels again.